Hi, I'm Tatum. Okay. Hi, I'm Tatum.
I'm Shravya.
And this is our project. So we're calling it the Catastrasense, and it was designed to inform users about potential future weather natural disasters, specifically in the Florida area. So there's a bunch of websites and stuff that relate to weather, and there's a bunch of databases about weather. But our program is made to be a somewhat like a user-friendly version of that uses AI and machine learning to predict whether there will be a natural disaster on a future date, including month, day, and year for a specific city in Florida. Um, so we'll go ahead and jump into our code.
Okay, so for the first part, we had two CSV files. So this is like the data cleaning part, and we merged them together based on the year, day, and month. So those columns were like merged together, and then also any empty columns in the no section or the yes or no had no's if there was no um, yes or no in it. And then we save the file.
And then the next part of our data cleaning was um, using that merged data set that has both the natural disasters and um, the weather data. So to change the zeros or basically, so the zeros in the data were saved as negative 99.9. So we replaced those with the NANs, but basically like they're the none cells. And then we replace those with averages of that column. So for example, for the precipitation column, if there had been no precipitation that day and our original data set had said negative 99.9, and to fix that, we changed it to not a number and then replaced all those with the average of the precipitation cells that weren't empty or like that weren't zeros. Um, so it was a like a lower number, but it's an average of everything in that column to replace the none cells. And that created a new modified data CSV that we could use for our user interface and pulling from the data. Oh, sorry, pardon me. And then for the rest of the merged data, we also had to add the Florida cities. So basically, we have all our data and we have it for the month, day, and year. And then to make it city specific, we have all the Florida cities in order to go into the database, and it places it and loops it through the columns so that all the each city has the accurate data points that go with it, so that when a city is called, which it will be called in the user interface for cities in Florida, it knows which points are associated with that city, and it can better predict whether there'll be a natural disaster on that day for that particular location. So that was all merged together in the modified CSV file that already has the natural disasters, the weather data, and the replaced empty cells.
So this next part is like the machine learning part. Um, so we first like figured out the x and y, so like the target variable and like the x. So the x variable was everything except for the yes and no column, and y was the yes and no. And then we trained the model using 25% of the data, and also used the label encoder to change so that the machine could understand what the strings were for the cities, and then we use the decision tree classifier and use that as for our accuracy and for the confusion matrix, because this provided like the best accuracy in it. And then, so our accuracy was 98.55%, and we had a lot of true negatives, not too many true positives, and this is because the data that we collected didn't have as much yet or didn't have as much yeses, so it didn't have a lot to base it off of.
Because natural disasters don't happen every day. Um, Okay, and then after that, we get to our user interface. So now that we have the machine learning established, we can go into how to use that for user inputting data and then pulling from our CSV file for whatever city they entered. So we have one city and two city. I'm going to go over the one city and then show the input for that. So if a user inputs one city, they'll also input a date after that. But these are all there's arrow codes for it. So it has to be a city in Florida. If you don't input a city in Florida, it'll ask you to input another city, but it can be all lowercase, uppercase, and lowercase, and any variety of that. So it'll accept um, a variety of cities as long as they're in Florida, written in real cities as well. They have to be real. Um, and then it'll ask you if you want to enter a second city, and we'll just assume we say no for now. And then it'll go to the date. So you've entered one city, you said you only want one city, and then you enter the date value, and that must be between 1 and 31 because there's 31 days that are possible to have within a month. And then you enter the month, which is between 1 and 12, which is self-explanatory, 12 months. You enter between 1 and 12. And then you also enter the year, and the year can be written as '03 or 2003, for example. And then after that, it'll pull from that year, month, and day. Well, it'll pull from that city and look at the year, months, and days for that city and determine whether there would be a natural disaster on that day in the future. So this is the predictive part using the machine learning, as I said earlier. So we'll go ahead and come down here, enter that, and let's say we go with, well, we'll do Gainesville. Um, and then you can do right yes and a weird, or we're doing now. So we can write now however we want, and I'll accept that. And then let's do the year 2030, the day 24, and the month 12. So it's going to say for Gainesville, which is the city that was inputted, it's not likely for there to be a natural disaster because it's December. It's not too hot, not too cold, not too rainy. So it's not likely. So it predicts that based on that month day in the past and compares and just basically looks at the year as a future, as like that's a future entity kind of thing. All right, and we'll go to the second city if you enter a second city now.
Okay, so for the entering a second city, it just pulls up like it's essentially the same thing, but it's twice. And you just enter in yes if you would want a second city, and it does the same stuff as the first city with the error handling and everything. And it like also goes into the data frame, and then if the user does enter the second city, it puts the user entered like city, and it uses the same year, month, and day that you put from before as well. So like it would be two cities, and you could look at it. You can compare them for the year, month, and day, and then if you go lower, you can see the it would you see the predictions, and then the next part would also like if you do enter a second city, it would show a graph of the differences between the precipitation and mean temperature for that city. And then for running it, we'll do Gainesville and Jacksonville.
All right, and for the year,
We can do 2030,
2030 as well. All right.
and then just do the first, and then first. So in this case, it's predicting that it's not likely for there to be a natural disaster in Gainesville or Jacksonville. And then these two graphs show the precipitation and mean temperature differences between the two places. And this is based off of previous data for that city and for that month that the model has. So it would show like what is expected to happen because the user does not input these values. This is also somewhat like of a prediction of what would happen.
All right. And then we go into our map. So basically, we wanted to create a map for these locations, and this is how the map knows where it is kind of. So we have ArcGIS, which is it's a like a huge database and program that knows where everything is in the world, and it's like a mapping program. For us, we used it to get the longitude and latitude of whatever city is inputted. So basically it's set to Florida. So like if there's another city in another state, it'll still pull from the Florida version, like Florida latitude and longitude. So if you put in Gainesville, for example, the ArcGIS package will just pull the latitude and longitude from that or for that city, and then we'll use that later in the map. And if there's a second city, it'll do the same for the second city. But if not, one is cool and it still works with just the one as well. So we'll go to the actual map. Ah, okay.
So for the actual map, it just basically plots where everything is. And you can see both cities if you zoom out.
Ooh, zoomed a little too far. Oh goodness. Okay, there we go.
Yeah, so there's and Gainesville, and then you can also like click on those markers, and it will tell you if there's like uh risk or not. So if you click on like the Jacksonville one or the Gainesville one, it'll say if the risk is likely or unlikely.
All right, and then we just have all the graphs. So the graphs, basically, they just pull from the data. So it uses matplotlib, and they're all 3D so that they can compare the month, day, and then an attribute of the weather. So it pulls from the different columns in the modified CSV file, and then all the data is truncated because there's too many data points to be able to. If you create a visual of that many data points, it just kind of looks like a block. So it's truncated to get an amount of points that are representative of years and all the months. So you can still be able to see all the trends. So there's one. If we go down here, okay, wow, I'm bad at scrolling today. So we have our maximum temperature. So if we spin that, let me make that bigger. Anyway, so the max temperature, and then you can see there's a trend with the max temperatures where they're higher in the summer months. And if you look, the min temperature has a very similar trend, but the scale is different. So this one's like 50 to 100. And then we can see the trend here, but it's with obviously lower temperatures, 30 to 80, normally maxing around 70. And that's also in the summer months, but they both have like the similar like rainbow trends. And then precipitation. So a lot of precipitation is going to be zero because it doesn't rain or snow. It doesn't really snow in Florida. It doesn't rain every day. So if you look at precipitation, you can see where rainfall is the heaviest. And then like which days they're the heaviest. If you turn it around here, you can look at the days and compare it. But essentially you can see it's normally around the eighth month, which is the start of hurricane season, which can be helpful in analyzing that data. Um, so yeah, those are the graphs.
Yeah, so that's it for like our presentation.
Thank you.